rotation, this lesson is pretty short and pretty sweet. And to do the homework tonight, you're going to need the notes for the rules. So make sure you're watching and paying attention because it goes pretty quick. A rotation is a transformation in which a figure is turned about a fixed point called the center of rotation. So, you have these snowmen on your paper, you have this definition, and we have center of rotation. This point right here, you actually have the dot on your paper too. This is called your center of rotation, and what happens is we take like the point on Frosty's foot and the corresponding point over here, and if from our center of rotation we draw in these two rays, those two rays form what we call our angle of rotation. So this is the blank on your paper to fill in your angle of rotation. And so when I have these two rays drawn in here, you could get out the protractor, we could go in, we could measure it, and like this is actually a 105-degree angle. You could take that, you could measure it on your paper, and you could come up with the same thing. So we have special rules for rotating figures around the origin. For a 90-degree rotation, this is the rule. The A and the B turns into negative BA. And so it's a matter of looking at and checking out what happened from this first step to this second step. How did they get negative BA? They changed the order and they changed the sign on this B value, right? So I don't know how you want to make note of this, but it's the B, we change the sign. We change the sign on it first, and then the order of those two flip-flops, okay? We also have a 180-degree rotation. The rule for 180 says, take the A, take the B, and change the signs. It's not necessarily always negative, it just means change the sign. So if it was negative 2, it actually turned into a positive 2. So that just means change the signs. And we have 270 degrees. The rule there is B negative A. Why don't we give you 360? 360, if you go 360 degrees, that's a complete circle and you'd be exactly back where you started, right? So we don't say 360 degrees. So those are your rules. Here we have 4 coordinates. It says graph quadrilateral KLMN with those vertices. Then we will rotate it 270 degrees about the origin. So let's go ahead and plot these points. K is at 3, 2. L is at 4, 2. M is at 4, negative 3. And N is at 2, negative 1. Why is it a quadrilateral? What makes it a quadrilateral? What's quad? Yeah, it has 4 sides. I don't have a special name for it, I just say it's a quadrilateral. So those are the 4 points, and I say let's rotate it 270 degrees. If we rotate 270 degrees, this is the rule from up above on your note sheet. The rule for 270 says AB turns into B negative A. So if I go B negative A, what do we need to do? We need to change the sign on the A is the sign that changes, right? So I would do this first. I'm like, well, the sign on the A changes, and then the order flips. So we change the sign on the A, and then the order reverses. So I change the sign on the A, and then instead of being first, it goes last. So like here, I change the sign on the A, I change the sign on the first one, and then it goes last. I change the sign on the A, and then it goes last. I change the sign on the A, and then it goes last. Does the B change? The sign on the B does not change, but instead of being last, it's now first. So I fill in what's left. This 2 goes first, this 2 goes first, this negative 3 is now first, and this negative 1 is now first. So I get those new points. And we have K prime, L prime, M prime, and N prime. It's the image, it's the new figure. So if we plot these points, K prime is at 2, negative 3. L prime is at 2, negative 4. M prime is at negative 3, negative 4. And N prime is at negative 1, negative 2. And this should be L prime. If if we rotate it, these rules are for going counterclockwise. If you look at the clock, what would counterclockwise be? Counterclockwise would be going the opposite direction. So instead of going to the right and following the second hand around, we're going counterclockwise, which is in the opposite direction. If I go counterclockwise and I take my original figure, my pre-image, and think about if you set it on my hand, this is how I always picture it. If I set it on my hand and I push it and I push it and I push it and I push it 270 degrees, that's where it would end up. That would be your new image. So how about here? I'm using the same 4 points, but now let's rotate 90 degrees and let's also rotate at 180 degrees. If I rotate 90 degrees, what's the rule for 90 degrees say? This is where you got to have your notes and you got to have it handy. Negative VA. 90 degrees is negative VA. So what are we changing the sign on? We're changing the sign on the B value, which is really the second one here. So however you want to do it, maybe this is what we do. Change the sign on the B, which is all of these right here. So I might go negative 2. This is negative 2, but what happens here? It becomes a positive 3, and this becomes a positive 1. We change the sign on the B's, and then we switch the order. So instead of K, K prime is now at, switch the order, negative 2, 3. L prime, change the order, negative 2, 4. L prime, M prime is at positive 3, positive 4. And N prime is at 1, 2. What happens if we go 180 degrees? What's the rule for 180? Negative A, negative B. So we change the signs on both of them. But does the order switch? No. So I change the signs on both of them. So I'm going to go boom, 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 change the signs on all these guys. And then you can clean it up. What is K prime? Negative 3, negative 2. L prime, negative 4, negative 2. M prime, negative 4, 3. And N prime is at negative 2, 1. We rotated 270, we rotated 90, we rotated at 180. If you can use those rules, you are in tip-top shape. And one last example at the bottom there. If a rotation is an isometry, what's that isometry word mean again? The side lengths are the same, and the angles are the same measure, right? Isometry, we keep all the lengths and all the angles the same. So if a rotation is an isometry, if I take and I push this, if I rotate this, everything should be the same. They should be the same measurements. So when I look at this picture, what parts correspond? If I push the pre-image onto the image, which parts would line up, match up? What would 7y match up to? 3x plus 1. If they're equal, we should be able to go in here and say, well, 3x plus 1 equals 7y. Can we solve that? With x and y? No. We can't solve an equation with x's and y's together, can we? So let's look at what else we know. What else corresponds? This 6 and this 3x also correspond. So if this is 6 units, this should be 6 units too. So we can say 3x is equal to 6. And what is x? X is 2. So if I plug a 2 in here, 3 times 2 gives me 6, so that this is 6, and this side is also 6. They match up, they correspond, they're the same lengths. They're congruent. So now, can I finish this? Now can I solve this? I know what x is, so now we can plug it in. So we have 3 times 2 plus 1 is going to equal 7y. Simplify. 3 times 2 is 6. 6 plus 1 is 7 equals 7y, so y equals 1. I have x and I have y. That's that. Short and sweet. Probably the shortest notes we've ever taken. In the first set, it says match the diagram with the angle of rotation. So here's your angle of rotation in here. So in number 1, is that approximately 110, 170, or 50 degrees? Match them up. And then I look at number 2, and I look at number 3. Of what's left, which one matches up to which? So you can match those up. 7, 8, and 9 say this. Rotate the figure the given number of degrees about the origin. List the coordinates of the vertices of the image. Does it say anything about graphing? No. It doesn't tell you to graph. So here's what you need to do. First list the coordinates, and then we're going to rotate them. So where is A at? -3, 1. B would be at -3, 3. C would be at 1, 3. And D would be at 1, 1. Those are the points. That's the pre-image. I need to rotate them 90 degrees. So here's where you have to have your note sheet with you tonight too. What's the rule for 90 degrees, tell us? -BA. So I know sometimes this A value is going to be negative. It doesn't mean change the sign on the A, it just means leave it alone. And this -B just means change the sign. It doesn't mean make it negative, it just means change the sign. So do what the rule says. Change the B and then swap the order. So I look at this and I'm like, which ones are the B values? These are your B values, right? So I change the sign on the B values. This is the B value. So I flip the sign and then we flip the order. So this is the B value. We flip the sign and then we flip the order. This is the B value. We flip the sign and then we flip the order. This is the B value. You flip the sign and then you flip the order. So what do we get? A prime would be at -1, -3. B prime would be at -3, -3. C prime would be at -3, 1. And D prime would be at -1, 1. So 8 and 9 and then 10, 11, and 12. Again, you have to list out all 4 coordinates off to the side, do what the rule says, and get the new ones. List all 4 coordinates, do what the rule says, and get your A prime, B prime, and C prime, and D prime. But you do not graph it. Sweet?